All right, so for 7.1, what we talked about is we talked about the central limit theorem for a group. All right, and whenever we had that group, what we found out was that inside that group, that it would be normally distributed. All right, now, as this says up here, it's the same thing for the sums of the group. So if you add up all of the numbers together for the entire group, what's going to happen too, as that sample gets bigger and bigger, then the sums will form their own normal distribution. So like I said up there, you'll have a bell curve with it. So a lot of the same stuff that we talked about with normal distributions is going to work for even when you add all the numbers together. Okay, now a couple things that still apply from what we did before was, first of all, the sum, okay, that is signified by this variable here, all right? And that is just adding up all the numbers inside your sample, okay? Now, you're not going to be asked to do that. More often than not, they're going to give that to you, so you don't have to spend the time doing it, but we do need to realize what that is talking about. Down at the bottom there, that's talking about the z-score. The z-score is still the same equation, all right? Okay, the sum of all the numbers minus n times mu of x over the square root of n times our standard deviation. All right, now for the mean of x, what that equals. Now, notice that the z-score equation, even though it looks different, it is still the same thing. The z-score equation normally is our number. Excuse me. Our number minus our average divided by standard deviation. All right, so when we're talking the average of all of these numbers added together, well, what that's talking about inside our equation is n times our mu of x. And then our standard deviation of this situation is still the bottom here, okay? It is still the square root of n times our standard deviation of that sample. Okay, so even though it's a new equation here, the stuff is really not changing. We just write it differently because of what we're given, okay? Does that make sense? All right, so a couple examples here. So go ahead and write them down. So we have an unknown distribution, has a mean of 90 and a standard deviation of 15. We have a sample size of 80 is drawn randomly from the population. Remember, once we get a sample size that where they tell us what it is, then we can do this, this normal distribution with the central limit. All right, so we need to find the probability that the sum of the 80 values is more than 7,500. So what we could do here is we could draw in a bell curve to kind of show what's going on here. What number do we need right down the middle of our bell curve? It is not 90 this time. Good try. We normally need to find the mean, right? Well, this time though, we're finding the mean of the sums. So for this, what we're going to have to do to find the mean of the sums, we're going to have to take our n, which is our sample size, times our mu of x, and that's talking about our average for that. Okay, now this is for the mean of the sum. So our average here for this situation is 7,200. All right, from there, we are trying to find when it's going to be greater than 7,500. So if we're going to draw in this bell curve, we'd put this line over to the right, and then we're shading in everything to the right of that. So we want to find the area of that because we're talking probability here. Okay, so this ends up being a normal distribution. So we have got to grab that calculator. We need to find the lower, the upper, our mu, and our standard deviation for each one of these. Okay, our lower is going to be what here based on what we're given? This is going to be 7,500. Okay, what is our upper going to be here based on that graph? Right, we got to type in that 1 EE99. All right, and then our mu, we already said, was 7,200. What's our standard deviation going to be for this situation? Not just 15. What else do we have to do? Square root of 80 times 15. Okay, and remember both of those for both the mean of the sums and the standard deviation of the sums, we're using these two equations that we just talked about here. Okay. All right, so you type that in and you should get an answer for me. What do you get? Should be pretty small. Okay, so 0.013, that is what I got. If you want to change that to percentage, 1.3%. Okay, both ways are right. All right, so it's really the same thing as what we did last week. Okay, we're just changing the equation just a touch because we're talking about the sums now. Okay, so we've got to find the average of the sums. We've got to find the standard deviation for those sums. That equation just changes a touch there. All right, down below, find the sum that is one standard deviations above the mean of the sums. Well, what do we do with that? What do you think that equation is going to be? We're going to take our mean of the sums, so our mu, of x. And then it's above, so we're going to add 1.5 times our standard deviation. All right, well, our mu of x was 7,200 plus 1.5 times, what's our standard deviation for the mean of the sums? That'd be the same thing that we did up here, right? So this would be the square root of 80 times 15. All right, what do we get for an answer here? Jacob, what'd you get? Haven't done it yet. Okay. What do we get for an answer? What'd you get, Jacob? 7401.2. Okay. All right. Okay. Any questions here? Notice though, this is the exact same equation that we've done before. Okay. This is still our average plus however many standard deviations above or below. If this said below, well, we just subtract that out of there times whatever our standard deviation is. This standard deviation just changes based on we have a sample size of 80. All right, any questions? All right, next one. Not next lesson. Nope.
I guess it is.
It's not a big deal. It's only a half-hour drive. You guys go ahead and try and solve all three of these. First two, you're doing a lot of the same stuff that we just did. The bottom one, we're gonna use a different function on the calculator. What did we get for mean for this? 1,700 is correct. All right, you just take the 34 times the 50. All right, what about for standard deviation of this? What do we get? 106.1, 106.07, yep, those are both right. Okay, we're taking square root of the sample size times the standard deviation there. All right, so you should get a 106.1 or 106.07. All right, what kind of distribution does this turn into? Yeah, this is normal because of the central limit theorem, okay? So when you're writing this down, the central limit theorem, you can just abbreviate by central limit theorem, CLT, if you wanted to. All right, for the second one, find the probability that the sum of the ages is between 1,500 and 1,800. All right, well, we know our average here is 1,700. If you wanted to do a bell curve, you might get asked this a little bit in the homework. Okay, we're putting our average down the middle. Then we've got to find our 1,500 and our 1,800. So we're finding in between those. All right, so then we've got to type in our lower, our upper, our mu, and our standard deviation. Okay, lower is going to be our 1,500. Upper is 1,800. Our mu we just found is 1,700. And standard deviation, I would type in the square root of 50 times 15, like that, just to make sure you get as accurate as possible. And technically, you could just type in 106.07. You'd get really close to it, but it is a rounded number in there. All right, what do we get for this answer here? That works for me. 797. Now, if you think about it, what we talked about before, okay, this follows approximately what we get for a bell curve. All right, our standard deviation is more or less 100 on either side. So it's 100 above, 100 below. Well, we've got to go 200 below. All right, and that would kind of follow what we're thinking here. All right, 68% falls within one standard deviation either side of the average. So it's got to be more than that. It's going to be less than 2 standard deviations. So it's going to be, you know, approximately about a half, like that shows there. Okay. So use a little bit of common sense when you're trying to figure out if this is spot on or not. Okay. The bottom one, I kind of showed the work for it already. Okay. Remember, when you're doing the percentiles for this, you don't use our normal CDF. We would do the inverse norm instead. Okay. Your area that they ask for is always the percentile, so change that to a decimal, so 0.8. And then we've got our average and our standard deviation already. So we just type those in, and we end up with 1789.3. All right. What does that 80th percentile stand for again? What's it stand for? Right, okay. Now with this one, what you said first was more correct. It's 80% of the sums are going to be less than that number, okay? Normally it was just 80% of the numbers are less than that, but you got to throw in the sums for this because of what this is asking about. All right, so that is 7.2. Any questions overall? It really is a lot of the same stuff. We just have to find them a little bit differently because these are the sums here instead of individual numbers. All right, any questions before we move on here? Questions, girls? What? Yes, we're doing 2 lessons. Okay. Question? Okay, fine, be that way. All right, 7.3 then. Let's keep rolling here. All right, 7.3 is all about using the central limit theorem, figuring out when to use it. Okay, as I have written up there are 3 main times when you use it. If you are trying to find the probability of a certain number, you use it. When you're trying to find the probability of a sum or a total, then you use it. It also works really, really well when you're trying to find percentiles, just like we did on the last slide there. When we're trying to find the 80th percentile, we're still going to use the same concept. All right, now, as it says down there at the bottom, if you are asked to find the probability of one value, don't use it. One value doesn't work nearly as well. Okay, instead, use the distribution that they're talking about in there. So that could be normal. If we know up front that it's a normal distribution, then yes, you would still use that. Okay, but remember those other ones that we talked about too. You might use a uniform distribution. You might use an exponential distribution. Okay, so that's where we have to use keywords to be able to find those. All right, so this section is all about trying to figure out what we would use when. All right, and that is where this gets a little bit more confusing. All right, if it tells you up front, oh, that's pretty easy to find out. Okay, if it doesn't tell you, then we got to figure out what's going on here. Are we good to go on here? All right, so here is one example. They are trying to figure out how much stress students are under at a certain college, all right? And they ask them simply, rate your stress based on what's going on in your life. Rate it between 1 and 5. Lowest is 1, highest is 5. They sampled 75 students. All right, so the first question that we're being asked here is we need to find the probability that the mean stress score for the 75 students is less than 2. All right, now before we can even find that, we've got to be able to find some information first. Do we even know what the average is here? We're not told what it is, but we are told it's what kind of distribution. It's a uniform distribution here. So we've got to go back to those equations that we learned in, I believe it was chapter 5, okay, to find our average here. For this, to find that average, we go A plus B over 2. What do you think our A and our B values are here? 1 and 5. It's going from the lowest to the highest, and then we got to divide it by 2. So our mu here is 3. Okay, we're going to need to know that one. The other one that we have to do is we've got to find our standard deviation of this. To find standard deviation for a uniform distribution, we're going to have, this is the square root of b minus a squared over 12. I was working on this last night. It took me forever to realize that the 12 is just part of the equation. It drives me nuts because it doesn't make sense to me, but the 12's in there. So, all right, B and A again are 1 and 5. So we're going to throw those in there. So we've got 5 minus 1 squared divided by 12. That gives us a standard deviation of 1.15. Okay, now that was all based off the uniform distribution. Okay, from there, now we can go answer the question. Okay, now remember what we just talked about is whenever you're trying to find the probability of a mean, the central limit theorem works out really well. Okay, but we have to use the right distribution to be able to find our average and our standard deviation when it's not given to us. Okay, so just be aware of that. Okay, so for this one, probability of the mean stress score for 75 students is less than 2. All right, so first of all, we're trying to find probability that x is less than 2. All right, so we're going to need that in a second. But what this turns into is this turns into a normal distribution because we're trying to find the probability of the mean stress score being less than that. So for normal, what numbers do we throw into this probability function? We would put our mean first of all, and then we would go, what is our second number? It's not just the standard deviation, it's what? Standard deviation divided by, say that again? Right, square root of the sample. All right. So that's what this would end up being. So you type this in, all right? And just like before, for this one, we would have our lower, our upper. Our lower here, what do we put in here? You remember? What's that? What do we put in? No, we don't put in a 1. 1E99? Negative 1. E99. Why is it negative 1 instead of positive 1? Positive 1 is going to be really, really big, right? Okay, you've got 99 zeros following that one. We put a negative 1 on there. Remember what that means? That just makes it a fraction here. So you type in negative 1 E99. Our upper is going to be a what here then? 2. Okay, and then we've got our other values here. Oh, that's a good question. Let me check this really quick first. You're right, that would make sense. All right, interesting thing with this one, whether you type in this, like I have up here on the board, or you type in a 1, you get the exact same answer. Okay, now the reason is that if we were to look at the bell curve here, all right, our average we found was a 3, right? We want to find less than 2, right? How much is our standard deviation? What does this number work out to be? 1.15 divided by the square root of 75. A little bit more precise than small. What is it? 0.13. So if we go based on what we were talking about before, 1 standard deviation over, we would subtract 0.13. We're down to 2.87. Okay, and we go even further, and we keep going and going and going. Okay, where that 2 is going to be way the heck over here, right? Okay, so it's not even how many numbers are going to be truly less than 2 based on this information. It's going to be very few numbers here. So that is why our answer ends up being a 0. Okay, so math-wise, when you're doing this problem, could you either go with this or with this based on what we're given? Both of them would work for this. Okay, technically, I think we should probably use that because that's the lowest value you can get here. Okay, but for this case, both of them would be the same. All right, next one. Find the 90th percentile for the mean stress score for the 75 students. All right, so first of all, what function are we going to use in our calculator? Yeah, we're going to use that inverse norm. And then the 3 things that we have to have here, we're going to have the area. The area is equal to what? 0.9. And then we've got our average, which is 3, and our standard deviation, which is the 1.15 divided by, and because we have a group here, square root of 75. Okay. Now I was talking to Max last week after when he was in here working on this stuff, and some of you guys were asking me, when do I divide by square root of 75 and when do I not? Okay. And I didn't even think of this. He just said, well, I just divide by whatever the group is every single time. Think about this. For some of those questions you guys were asked in your homework, the group was not 75. The group was 1. You just put a 1 down here. Then it makes it very simple. Okay, you're always dividing by however big the sample size is. Yes, sir. Yeah. So right. So what's the square root of 1? So it doesn't change anything, right? Some of the problems that you guys were having last week was you didn't know whether you should divide by the square root or not. Okay, so what he just decided to do, and this is mathematically accurate, if your sample size was 1, well, he just kept going, whatever the standard deviation is, divided by however big the group was. Okay, that'll work every single time. That way, you don't have to think about it. You just automatically do it. Okay, so I didn't think about that. Max said it worked. I looked at it. It works every single time. All right, so what do we get for this answer here? When you type all that in there, what do you get? 3.17. That works for me. 3.17. Okay, remember 90th percentile means it's going to be above the average. And as we started drawing up here, okay, it's going to take a while to get to that 90th percentile, or it's not going to take very long at all to get to that 90th percentile. All right, so this is a way to get to that very quickly. All right, we do have 2 more questions along with those data points there. find the probability that the total of the 75 stress scores is less than 200. Now there is a keyword in here that tells us something extra that we're going to have to do. What is that keyword? Yeah. I don't see sum up there. What are you talking about? Total, right? Okay, I know it's the same thing. All right, but it is, okay? So that is telling us that we're going to have to find our average and our standard deviation a little bit differently this time, aren't we? Okay, so we have to find our mu of x differently. How are we going to find that this time? It's not just a 3. It's a what? Yes. So our sample size is 75. Our mu was 3. So our new mu value for this situation is 225. All right. We're going to have to do the same thing for our standard deviation. How we find our standard deviation is the square root of our sample size times the original standard deviation. And that ends up being 9.96. Okay, so even though they're not asking for those two values to be able to get this problem, you're going to have to find those. Okay, and so from here, probability, so we're thinking normal distribution here. Okay, so we're going normal CDF. We want to find less than 200. So this is going to be, what are we typing in? We've got lower, upper, our mu is 225, and sorry, not that, our mu is 225, our standard deviation is 9.96. Okay, Caitlin says for our lower, we do -1 E99. Do we do that here? Don't matter. You get the same answer for both for this. All right, so we can type in a 1 here, and then for our upper is 200, and what do we get for an answer? So better known as, or 0.6%, sure. Okay. All right, many times what you'll see in the answer key for this is it'll say about 0. Okay. I think this is a better answer personally, but either one would be fine. All right, letter D, the 90th percentile for the total stress score for the 75 students. Okay, so we're doing that inverse norm here because they're asking for a percentile. Inverse norm, our area is the 0.9. Okay, and then we've got our mu, which is 225, and our standard deviation, which is 9.96. And what do we get for that one? Mr. McKinney, what'd you get?
I've been telling you all the answers.
I know.
236.
236, really? Nice try. That's what it should be. All right. Any questions with this one? All right, we got one more to go here, I think. Please, people. No, I lied. We got 2 more to go. All right, let's go. Stop whining. Let's go. It's too much. We've done all of, this is what, slide 6, 7? Slide 7. Deal with it. Oh, no. And I even shortened up these notes quite a bit. Now, as you're writing this stuff down here, all right, you see, first of all, question A and B are very, very similar there, okay? Find the median, first and third quartiles. What is that talking about? Median is what percentile? 50th percentile. Right, we are trying to find the 50th, the 25th, and the 75th percentile. So we're doing a lot of the same stuff that we did on the last slide there. All right, so for this first one, to find those percentiles, we need to find the sample, or for the sample mean time, we've got to know, do we have our average here? Are we given that? What is it? 2. Yeah, every 2 minutes. So they didn't say it specifically that the average was 2, but how it's written there, it's given to us. All right. For our standard deviation, for this one, what does the standard deviation end up being here? We have a sample size, so we're going to have to divide. So 0.5 divided by the square root of 100. So 10, yeah. So our standard deviation is simply 0.05. Okay, so for this, okay, we're doing a lot of the same stuff we just did. Okay, and they're going to, in your homework, you're going to get asked a lot of different questions very similar to this. So we're going to do the inverse norm of the 50th percentile. So that's area is 0.5. And then we just type in our numbers here. So our mu is 2. And our standard deviation is 0.05. So we should be able to get all 3 of these very quickly after you find those 2 values. So give me some answers. Get your calculator out. Huh? For all 3 of them. So do it. Give me an answer. Sarah, I'm waiting for you to give me the answer. Jacob, does that mean you think you got it? You got what? It's 2. I already told you the average was 2.
She's right though.
Why is she right?
50th percentile is 2.
Oh, why is it the same as the average?
It's already the average.
Because it's a bell curve, right? Okay. So because it's a bell curve, your mean and your median should be the same. So our median does end up being 2 here. I was just asking you to think. That's all. I did not say that at all. Didn't even think it. I did not. What did we get for the first quartile, Jacob? What? I know you have it done. 1 point what?
966.
Okay. 1.966. That's where that works for me. What about for the third quartile? 2.03. Okay. That works for me. Now, these should be the same distance away from the median, shouldn't they? Okay, because of the bell curve concept. Now, for the second one down there, we're not going to do all of it. It's okay. I know that you guys know how to do this now. Okay, the biggest thing, though, is we have to find our mu just a little bit differently and our standard deviation just a little bit differently here, don't we? Okay, we're talking about the sum now. So it's not just going to be a 2, it's going to be a what? It's going to be a 200 because we got to take our normal average times the sample size. So that's going to be 200 then. All right, for our standard deviation, how does that change? Square root of the sample size, which is 100, what goes on top? Hmm? Right, right. I know. I wrote it differently on purpose. Make sure you guys got it.
Yeah, for sure.
You guys. So what do we got? Square root of 100 times what? Not equals. Times what? Times 0.5? Yes. 0.05. Yes. All right. So, no, it's not times 0.05. It's times 0.5. Yep. My bad. So we get an answer standard deviation this time of 5. Okay. So you're going to do all the same stuff with those two numbers now. Okay. The median. Do we have to type that in, or do we know that the answer is 200? Okay. And then the other two are pretty, you just type in all the stuff, right? Do we need those answers, or can we move on? All right. Okay. Last one. This one is different. That's why I put this one up here. And I did not even put down all the questions that they want us to go over here. This was an A through E. I gave you A through B. What kind of distribution is this one? This one's a little bit harder to pick out. We haven't done this one in quite a while.
Random.
No, not random.
In Poisson.
You're closer.
Random.
That is correct. Why is it binomial? And tell me why. I know you just threw stuff out. Tell me why it's binomial.
No.
It's been a while, I know. Huh? No, not because of a group. If you think about this, okay? Think about what the answers are going to be for this. What answers can you have for this? Not just whole numbers, okay? The question might be, are you in favor of a charter school? Yes or no? When you have two options, it is automatically a binomial, okay? Two options is a binomial. All right, now for binomial distributions. All right, how we find these things are a little bit different. Okay, so you might have to go back in your notes and be able to find what's going on here. For our mu value, that equation, I'll give it to you. You don't have to look it up. Our mu for this is n times p. What does n stand for? Sample size, which is 300. What do you think p stands for? Probability, or the percentage here, right? So this is going to be 0.53. So 300 times 0.53 is 159. All right. Our standard deviation for a binomial. That equation is going to be the square root of NPQ. All right, well, what we said about our N is the sample size. Our P is the probability of a success, so that's 0.53. Our Q then would be what? Probability of a failure, which would be 0.47 here. P and Q should always add up to either 1 in this case or 100%. Okay, so we type that all in the calculator. We get a standard deviation of 8.6447. McKenna, what was wrong with that? Okay. Okay. All right, so remember, we've got to use the different equations to be able to find our average and our standard deviation. So this one is going to be, if we put this into our distribution, this would end up being a normal distribution because we're trying to find the probability that this happens. All right, our average is 159. Our standard deviation is 8.6447. Okay, so now this is where it gets a little bit trickier. Okay, find the probability that at least 150 favor a charter school. So what we're truly doing here is we're trying to find the probability that X is greater than 150. Or greater than or equal to. Now the or equal to is important here. Okay, when we have that, when we type this in, we're not going to use the 150. Remember how we had problems with that early on? Okay, what was that? Close. Okay, what we would do, yes, for some of your calculators where it's already included, you know how to deal with it, okay? But for this, what we're going to have to do is we're going to have to change this equation into X is greater than 149.5. Okay, the reason why it's 0.5 is that would round up to the 150. If we just did a 149, that's completely separate, isn't it? Okay, so this would have to be a normal CDF. Okay, our lower would be the 149.5. Our upper would be how much? Very good. 1E99. And then we've got our mu value of 159 and our standard deviation of 8.6447. If we use those numbers, what do we get for an answer here? Right. All right, so what that is saying is we know our average is 159. Say you want to find the probability that you need at least 150 votes. Okay, based on what you're given here, 86% chance of having at least 150 votes. Okay, how do things change in the second one? We don't have to do the whole thing, but how does it change in the second one here? What does that most mean?
16 less.
Okay, it's going to be less than 150, right? Sorry, 160. Yeah, helps to read. Okay, so, but we're not going to do the 160 there. We're going to type in what? 160.5. Okay, we're going to add 0.5 this time because we got to make sure that that 160 is involved in there. All right, and then from there you do all the same stuff. Okay, so lower is going to be what this time? You can do that, or you could type in a 0 there, couldn't you? Okay, 0 technically, it would probably cause it to kind of malfunction. So that's why you got to go -1 E99. Can your calculator do 0? Okay, depends on your calculator then. Okay, and then everything else is the same. You just got to make sure we're plugging it in right. Okay. All right. So, ladies and gentlemen, what you should have gotten out of today, okay, is first of all the new equations that we changed a little bit today. They're not big, huge changes. They're pretty much the same thing that we've been doing. The problem is going to be what type are we going to have to do this with? Okay, that's going to be the hard part for everything that you're doing today. All right, can you think of any questions right now? All right, homework assignment is right there.
Holy!
I made it the odds. I could have just made it the whole thing.